Basic structure of a typical C program. A typical C program has 5 basic structure, which are the preprocessor command, the functions, the variables, the statements and expressions, and the comments. This is a typical C program structure. The first two lines here are the preprocessor commands. The other line of code, which is the main, is the function. Now the variables are not yet declared. The statements, these are the statements, but this is just program structure of a C program. It has the preprocessor commands, it has a function, and it also has statements and expressions. Now let's go deep into all these structures. The first two lines is called the preprocessor commands. This is a preprocessor command which tells a C compiler to include standard input output file before going to actual compilation. Now this allows our program to have an input and output functionalities. For example, this print statement won't be available if this first file is not included. This first preprocessor command says that it should include the standard library for input, which is the I, and the output, which is the O. And this is a header file. .h is a header file. So the library for printing and imputing data into your C program lies on this line. Moving forward, this main function here is the main function where our program begins. If we don't have this main function, our program will not run. So this main function is just an entry point in our program. So each program has an entry point. So all your C programs, it must have one entry point, which is this main. The next one is the printf statement. Now this printf function allows you to print message such as hello world and any other message to the screen, and it is made possible by this include function up here. So anytime you want to print out anything on the screen in your program, we use the printf function. Next in line is the return statement, the return 0. What it does is it terminates the main function and returns the value 0. Whenever your program runs successfully, it returns 0. It terminates and returns 0. But when your program didn't run successfully, when it has compilation error or runtime error or syntax error, it will return 1. So it will terminate your program and then returns 1. But when your program runs successfully, it will return 0. So this is just the basic structure of a C program. It must have this preprocessor commands, include statements, and it must have the main function. And inside the main function is going to be our codes, our variable declaration, our data type declaration, and whatever our function call up and other things are going to be inside of this main function. Let's run this code. So it brought us hello world. Now remember, I told you that the print function, this printf function, displays whatever we put inside of it. You can see we entered hello world inside of it and it brought it out here. That is to show you that this print function is used to print something out of your program to the screen for your user to see. Now this return 0, you can see the process returned 0. That means everything worked fine. Assuming there was an error, it's going to return 1. Okay. In our next program, we are going to talk about data types and variables. Before we begin talking about variables and data types, let's talk about syntax. What is syntax? Syntax is a set of rules that define what the various combination of symbols means. So A syntax is an instruction that is being given to our C program, which determines the various combination of symbols, what they mean. For example, we have this print f. Now this is a syntax and is a set of rules. So for us to print out something on the screen, we need to call up this function. Okay, and we need to spell it accordingly. For example, if we now left out the termination mark, this rule here right now is going to be violated because we missed out some sets of rules that we need to undergo for our program to be successful. Okay, so syntax is just a set of rules that define what the various combination of symbols, all these things here now are sets of rules. We followed rules while declaring or while writing all these things. So we followed a set of rules that define what all these things, the combination of all these things here, all this code that we wrote here, what it means to the C compiler. So it's going to translate this into a meaningful instruction. Next is data type. What is a data type? A data type in C refers to an extensive system used for declaring variables or functions of different types. Now, the type of a variable determines how much space it occupies in storage and how the bits pattern stores is interpreted. So to break it down a little bit, a data type is just a format that we use in storing data. For example, if you create a folder called videos, you will store videos inside of those folder. So the data type now is now called the video data type. If you are storing audio, now the data type is now called the audio data type. So audio files cannot go into video files and video files cannot go into audio files. For example, when you have an empty can or an empty bottle, now you gave it a set of rule or a data type saying this bottle is going to contain only soda. Water, sand, or any other cannot contain it. That is a typical example of a data type. When you set a data type of a particular thing, no other object, no other variable, no other value except from the one that you set can occupy that position. We have 5 types of data types. We have the basic data type, the derived data type, the enumerated data type, the void data type. Now let's go to the basic data types. We have the floating point, we have the integer, we have the double, and we have the character. The derived data types, we have the union, we have the structure, we have the array, etc. The enumerated data type, we have the nums. The void data type, we have the empty value. The integer, we use this for storing various whole numbers such as 5, 8, 62, 68, 67, 2390, and etc. Character, it refers to all ASCII character sets as well as the single alphabet such as XY. The double, this includes all large types of numeric values that do not come under either floating point data type or integer data types. The floating point, this refers to all the real numbers values of decimal points such as 40.1, 820.673, 5.9, etc. The void data types, this term refers to no value at all. We mostly use this data type when defining functions in our program. Variables. What are variables? A variable is nothing but a name given to a storage area that our program can manipulate. Let's go and practice what we just read. Remember when I said something about integers? So we are going to talk about integers. if you want to declare an integer, remember an integer is a whole number, or integers accept a whole number. It doesn't accept decimal numbers. Okay, so we declare our type int, then our variable number, or you can name it anything. Let's go with x. Now this variable is just a memory location that we labeled x. Now we are now telling this memory location that it should accept only integers. Anything apart from integer cannot enter into this variable x, or cannot enter or cannot be stored inside this memory location called x. It only allows integer values. Now this is called variable declaration. In our program, we can have multiple variable declarations depending on the use, if you need it. So all these are variable declaration of an integer. So we have declared variable x, y, and z, and we assigned it a data type of int. So all these variables right now is a memory location that we labeled x, y, z, that only allows integers, which are whole numbers, to be stored inside of them. Now let's proceed with our initialization. Initialization means assigning values to our variables. Here we declared it, and now it's time for us to initialize it. Now remember, they are all of integer data types. So we reference the variable, which it has already been declared here, so it is visible here. But if you did not declare this variable x here, you declared something else, and here you come and put another name that is not part of this declared variable, it's going to throw you an error. So when you declare something, you can use it anywhere in your code. So let's continue with our initialization. So x, we have the value of 12. Now y, we have the value of 13, and z is going to have the value of 1. Okay, now you can see that all these values are all whole numbers. They don't have anything like decimal in them, no. But if you are initializing your own variable of type integer, and you now put the value of a double, like a decimal number, on an integer data type, is going to throw you an error. So this will return error, but this will return true, which is correct. This and this will return true, correct. These are correct, but this one here, this z is wrong. So because it has the data type of integer, but you are giving it a value of double or float, so it will come out error. So for us to correct it, we make it a whole number 1.